Hello, this is Rishabh Daga again. This will be my second video for my second digital assignment for computer organization and architectures. So I'd like to keep this video short and informative. So let us start. My paper's topic was implementation of 14 bits floating point numbers of calculating units for neural network hardware development. So we'll start with the very first question. Explain how the selected paper relates to the COA syllabus and curriculum. And this is a very straightforward question. The one of the outcomes which I took directly from the syllabus was to understand how basic arithmetic operations are implemented in cow and sign multiplication and divisions are carried out using Booth algorithm, right? So this is uh, for calculating units itself. So it's a very straightforward question with a very straightforward answer. Now, EPS format using raster graphics editor software for the existing architecture. Again, as I explained in my first DA, I drew this in raw.io. I saved it in .io file and then converted it to JPEG and EPS format, which I uploaded in my Google Drive as well. So this is the where I've uploaded all my stuff. This is the existing hash in raw.io. So if we download this and it's downloading. So if we download and save this and open this, I actually have the raw.io software installed in my system. So when you open it, you get this whole thing. As you can see, each block, each arrow is editable, which means I've drawn this myself. No scope of cheating, no scope of nothing. All this I've written on my own, and that's the entire thing. So this is one of the questions. Now let's move on to the next question, the third question. Draw the tabulated results and graphs using Office Suite. This I made using the Word. You can actually do this in Word itself. Let me open a Word real fast and show you how I did this. So blank doc. Now let's go back here. Again, before I show you how I did this in Word, these are the tabulated results. Let me show you where these are. So this is the journal paper, and here we have the results in tabular manner itself. So yeah, I'll go back to where I was, sorry. Yeah, and if you want to do this, you can go in Word, you can insert a table, and here Word is really good at all this because like you can select the number of tables, sorry, the rows and columns you want in a table like this, and you can write. This is exactly what I did here. All of this editable in Word, and there are 6 columns, 3 rows for each of this. So that's pretty good. I'll just delete this. Don't want this taking up space here. So, yeah, now we move on. This is the figure from the journal paper itself. Now this is the proposed architecture using diagramming and vector graphics application. Again, I did this in raw.io format, and the .io file as well as the EPS, which the converted file from .io to EPS I uploaded in Drive. So let me show you the proposed architectures, right? So this is the da2.raw.io. Again, we'll download this. Will take a couple of seconds. All this I am doing in front of you in the video so that you can see that this is verifiable. This is actually not cheated. All this I've done on my own. Each block, as you can see, is again editable. You can shift it. So this is proof that all this work I've done on my own, all this stuff I've done on my own, and this is basically it, as you can see. So I just this took a lot of effort, and honestly, I this was fun because I got to learn and experiment with so many new softwares and stuff. But yeah, so we'll move on to our next question. Again, the transistor level internal diagram. This is from the journal paper itself for the electronic schematic capture. The simulation tools were something not available in my journal paper, so we'll move on to the next question. Now, I think sir asked me in class about the comparison questions with the proposed architecture and existing architecture, and I showed you this, and I think it was very pleasing to note that I had done this in a tabular manner, and this is from the paper itself, whatever it was: faster search of maxer elements, solo search, the power and the storage, all this was there. The advantages of the proposed design, again I'll show you this in the paper itself, again in a tabular manner, the merits and demerits and the applications, all of this. Now again, the transistor level circuit version draw.io, and the algorithms as well, let me show you. So this is the sorry, multiplication algorithm and the addition algorithm. I'll not open these because these are normal algorithms that are editable again, which is easy verifiable, because you can open these in draw.io and see that each block is individually movable, which is not the case if you just copy paste a diagram over there. So that is proof. And this is my journal paper in which the addition, subtraction and the scheme of the hardware floating point adder is given here. The results are also here. The applications were given right at the very start at the problem statement, and the drawbacks are also given here. So overall, this was a nice paper which gave me a lot to learn, and I'm glad I did this DA. Thank you.